Welcome to this talk about damage optimization in video games. This paper has been published in the 2024 CHI Conference in Human Factors in Computing Systems and is accessible via the link in the video description. In this work, we will focus on dealing damage. While this might be important, how to analyze this and how this can be optimized from a user-centric perspective, either developers or players with or without assistance of AI. Damage is almost omnipresent in modern video games, as a major share of genres builds on combat and/or competition. This can be, in a classical sense, the strength of your attacks, so spells in action or role-playing games, or the amount of harm your projectiles inflicts in shooter or battle royale games, or the strength of your units or armies in strategy games. Even in traditional puzzle games, we often see blends of damage elements nowadays, and even in racing games where everything ought to be up to speed, also often incorporate a more destructive nature. So this is nice at all, but why look at that scientifically? Well, modern video games have the potential and tendency to implement quite complex damage mechanics, to let players evolve and optimize, keep the game diversified, interesting, and enable multiple viable playstyles. Even in genres that used to be heavily focused on reaction time and aiming, such as first-person shooters, modern games often have plenty of different passive modifiers to choose from: weapon properties, active abilities, interactions between shooting, jumping, reloading, killing, and so on and so forth. So why is that interesting? Because from the player side, understanding damage is not trivial. There is never a developer's manual or how to play the game best. Yet this is often desired by many players, especially in competitive environments. Mismatches between a player's proficiency to efficiently deliver damage and the challenge a game offers can harm the player's perception of flow, because it can easily be frustrating or, of course, boring if the challenge is not complex enough. Yet, if this level of understanding is only superficial or obscure, the only resort is to spend a lot of time in just playing, often without proper feedback or knowledge what parts of their gameplay were better or worse. People are spending too much time sitting in front of the screen anyway, so any efforts that we can do in order to accelerate or optimize that process is not a bad direction, I would argue. On the other hand, the more wild and complex it gets, the harder it is for developers to actually keep an overview which constellations, builds, strategies, and gameplay are leading to what damage potentials, which can mean that characters or classes or builds of the game are way too weak to compete with all the alternatives, rendering them inviable, or some approaches are just so overpowered that they might break the game. Both can cause a lot of frustration, in the worst case, players stopping to play the game, and lead to constant game balancing adjustments, as we have it with every running online game nowadays. Any efforts to get numerical insights before economical harm is done or before player experience is affected is also worthwhile to study. Certainly, inflicting damage is not the only crucial dimension that determines the success of a combat or match, as often strategical movement, reaction speed, predictive capabilities, communication, and other factors are more decisive for the fight. But learning how to optimize one's own damage potential and how to make the most out of the player's character's possibilities is considered essential for success and efficiency.
This is why we wanted to look at that more strategically and to estimate how we could intervene best in order to foster the understanding of how damage unfolds. First of all, we cannot operate directly within most games. So how can we build a system that models damage in a generic form? This has been realized in a general and customizable simulator, which uses a game's damage formula, a character, and a set of actions in order to calculate which amounts of damage would result at which timestamp of the fight, on top of which we implemented an interactive front end. Then we are here on the CHI conference to especially have the human in focus. So what do users, in this case players, that seek to foster self-improvement and understanding of damage need and desire? For that matter, we reached out to a player community, let them evaluate our damage optimization tool, and report their opinions, stances, and requirements. Last but not least, these efforts would not be proven valid if not evaluated empirically as well. So I'm happy to spoiler you that we found a significant impact over expected performance increase as well. For at least the two last research questions, a case study was necessary to get a valid answer, so let me give you a little bit more context. We chose to reach out to the community of Guild Wars 2 as depicted here. First of all, because its combat has shown to require perception, memory, motor skills, anticipation, timing, accuracy, coordination, response selection, and other dimensions, so it is complex enough to warrant an investigation. Second, we already have access to an engaged community that is interested in self-regulated learning, data analysis, and contributing to science. And for those of you who attended my last year's Chi talk, we are running a player-driven analytics platform that delivers us a big data set that really helps with making any quantitative performance investigation. But now I will talk less about the data and more about the technical artifact of this work, the simulator plus interactive front end to generate insights about damage outcomes, which we together call the rotation optimizer. To be more precise, everything in the center box here is part of the request for one simulation step. So we have a set of characters. In the easiest case, it's only one player and one target. Each character has a build. A build consists of actions that could be executed by the player. They can have an animation time, damage coefficients, they could trigger effects or apply status conditions, change variables in the game, and might not always be legal to execute at every time step. There's also a set of permanent or temporary effects in this build, which can be triggered by actions or other effects, can affect variables or character attributes or the like. Character attributes and some internal variables are also included here. And now the last thing the simulator requires is a rotation, here defined as a sequence of actions by timestamps, often one after another, to compute the end result. What we get is a series of events per timestamp, which could be actions executed, effects triggered, or damage occurred to any actor. All of the in and output is in JSON format, which is of course very cumbersome to interact with as a user, which is why we added a web front end that makes it accessible to people without code knowledge. So in the lower half you can see the available actions of that player character at any given timestamp, in this case start of a fight. Users can click together a rotation, so a sequence of action. This gets processed by the simulator in the background, and the damage over time would be represented in the upper half. In this case, you see a damage over time progression for the first seconds of a fight. This optimizer supports multiple strategies, so you can just add another tab and compare what would change in the damage progression if you did a few things different while having the same setup as before, or what would change if you changed the setup while having the same rotation. Also, if you're not interested in the damage over time, there's also a distribution overview per skill or per action that can be compared as well. Just as a comprehensive list of all events, uptime of effects, a journey network graph of the most probable rotation, a summary of the largest differences among all the data, and more. I can't go into detail about every feedback mechanism here, but feel free to refer to the paper or contact me directly for more insights. What might be noteworthy here though is that you can also import actual logs that you or other players recorded from in-game and compare them to simulations of action sequences that you want to test. So this is kind of a novel way of inspecting your gameplay and damage-related outcomes and actually apply counterfactual reasoning, or what if I did something different here or there, without the need to test it in-game, without the perfect execution of this behavior, and without the noise that often appears in-game or from random variables. But it does not stop at this manual exploration of strategies. As I've dropped the buzzword AI earlier, we can also represent this sequential decision making as a game tree or Markov decision chain and run classical AI algorithms over that. For the purpose of this study that we will come to in a minute, we only used greedy search with customizable rewards and breadth first search, since these are easy to understand from a user's perspective. And that of course also allows you to say, hey, I want to import my gameplay, compare it to what AI would have done, and get the largest differences in behavior visualized and how I could improve. Getting back to this flowchart, you can hopefully grasp it a bit better now. Users start here on the top with a visualization of empty gameplay and can explore manually or with the help of AI what next action should be taken. This gets added to the rotation, simulated and interpreted. For the sake of informing AI, but also the user, rewards of that choice will be calculated that are displayed in some of the tabs and can influence future decisions. In the end, it loops back to visualizing the full state of events, progressions, distributions, and so on, so that the user, or AI, can take a next informed step. Now let's see how players of the case study actually would want to use such a tool. I will not read out loud every of the qualitative questions that we asked them, but try to sum up instead. More details in the paper. In our qualitative study, we had 32 participants that gave feedback after using our rotation optimizer. Most of them were either intermediate or already expert players in the game. They indicated to have used the tool to get informative visualizations, to compare their own performances to others, to prove that theoretical strategies are viable, and more. As we aim to develop 8 for all expertise levels, we asked how this could be beneficial to different audiences. So in the beginning, they replied that such a tool can be good for an initial but also deeper class understanding, for the comparison to others, and for revealing and overcoming bad habits. Some indicated that this tool might be a bit too complex for beginners though, which however could be overcome with mentoring. For higher experienced players, they already know their classes well, but can use this tool to tailor their strategies precisely to the encounters that the game offers, or explore benchmarks, that is, the most optimal rotations under ideal environments as soon as or even before a new balance patch hits. None of them denied that this tool can be beneficial for understanding or actual improvement in the end. And since AI is a bit of a hype topic and some could have also perceived such tools as cheating, we asked for their stance of AI to foster self-improved learning, which they largely accepted or even expressed enthusiasm. They also mentioned some very in-depth details which can be found in the paper, but now we jump right to the consequence that inspecting and exploring damage could have. So as I already said, we looked into a database that records player performance on most of the game's bosses and compared players who used the rotation optimizer versus the same amount of players who did not. More specifically, we did not compare the raw performances as indicated by their final damage per second scores per boss, but the improvement of this performance metric over the course of 5 weeks. So we took data from 2.5 weeks before a player's first usage of the rotation optimizer and data from 2.5 weeks afterwards, and compared if they significantly improved and how much relatively. After cleaning out the data points, screening for enough samples per player, and fulfilling normality assumptions, we ended up with 717 players in the intervention group, from which 24.7% improved their gameplay significantly when comparing the first 2.5 weeks versus the post 2.5 weeks. That sounds good, but we also have to compare to the control group since a bit of improvement is expected. Here we only got 19.1%, which, if applying a chi-square test, is significantly lower than our rotation optimizer users. Next, we also looked at how much they improved relatively based on their normalized performances, which was plus 6.3% on average for our intervention group and only 2.3% for the control. There were large variances though, but a t-test between those scores indicated that our intervention group improved more relatively than the expected amount of the control group. This was their performance on actual game bosses. There's also a training environment in which you can practice your gameplay. We have less data that fulfills all assumptions here, but it paints the same picture. Twice as much players improved compared to what you would expect, and on average they increased their performance by 4 times of what non-users would have scored. So to wrap up very quickly, we build a nice tool that simulates damage in video games and visualizes this interactively. In the context of Guild Wars 2, it has been shown that this is over 99% accurate to in-game numbers, has already predicted the impact of some announced balance patches, and has found rotations that were better than the best human players before. Next, we evaluated this towards refinements, future features, and aggregated how players would like to make sense of such a system. This can obviously be very different for other games and genres, but we started here and wanted to go deep before going broad. And finally, great relief, it actually helped people to find out some of their bad habits, suggested better combos, priorities, or whole rotations, up to the point where a performance increase above the expected level is measurable. Of course, it might be that the sample that used our tool was a bit skewed to higher experience, but then again, people who are already high performing can naturally also not increase their performance as easily as beginners because of the practical limits. Apart from other structurally very different games, as you can see in the supplementary material, we are also bringing more recent AI advances like PPO into the optimizer, but this is it for today. Thank you very much for your attention. I hope I could spark a little interest on how to optimize damage output, how this can be visualized and explored, and why this can be interesting for players and developers alike.